Hello everyone, my name is Huilin Zhao. Today we studied Functions 11, Chapter 1, Introduction to Functions. The topic is inverse functions. The inverse function and its properties. What is the inverse function? The reversal of an original function. Example 1. Determine the inverse equation for the following relations the graphed and identify whether functions are not functions. Number 8 is the points. There are 6 points. You can see the graph. P1 is -3, 1. P2 is -2, 1. P3 is -1, 1. P4 is 0, 3. P5 is 1, 0. P6 is 4, -2. Number B, fs equal -3x over 5 plus 3. Number C, fs equal 2 minus 5x. Solution 1. For the 6th point, we are going to find the inverse relation. So the coordinate, the x and y exchange. And then get a Q. Let P1 to Q1, P2 to Q2, P3 to Q3, P4 to Q4, P5 to Q5, P6 to Q6. Let's see the detail. Let P1 is -3 and 1, so the Q1 is 1, -3. And P2 is -2 and 1, and the Q2 is 1, -2. P3 is -1 and 1. Q3 is 1 and -1. P4 is 0, 3, and the Q4 is 3, 0. And P5 is 1, 0, and Q5 is 0, 1. The last one, P6 is 4, -2, and Q6 is -2 and 4. In the graph is the green one. When x equals 1, there are -3, -2, and -1, two corresponding to it. So this is not a function, because the one x value have more than one y value to correspond to it. So for the inverse relation is not function. Number B, for fs equal -3x over 5 and plus 3. How to find the inverse relation? Actually, there are 3 steps. Step number 1, move the term increasing independent variable x to the left side. 3x over 5 equals 3 minus y. Step number 2, separate s as a single. And then the both sides multiply the 5 over 3. So you can get the x at the left side is single. And then equal 5 minus 5y over 3, because it's 5 over 3 times 3 is 5. And next is 5 times y over 3 is negative here. Step number 3, x and y interchange. Then rewrite y into f -1. So this the inverse function is y f -1 equal -5 times s over 3 plus 5. And then the graph is two functions. The original function is the green one, and the inverse function the f -1 equal -5 times s over 3 plus 5 is the purple one here. So they have the one intersection point. The coordinate is 1.875 and 1.875. We can see that both are function. Actually, it is a linear function. Solution C. For fx equal 2 minus 5x, there are 3 steps to find the inverse relation. Step number 1. Move the term increasing independent variable x to the left side. Get a 5x equal 2 minus y. Step number 2. Separate x as a single. Add both side terms 1 over 5. So for the left side, leave the x, and the right side is 2 over 5 minus 1 y over 5. Because in the right side is 1 over 5 times 2, so that they get 1 over 5. Another one is 1 times y over 5, and this is the minor. Step number 3. X and y interchange, then write into f negative 1. The inverse function is f negative 1x equal 2 over 5 minus 1x over 5. The graph here. The red one is y equal negative 5x plus 2. We can see the y-intercept here is 2. And the inverse function f negative 1x equal 1 negative 1x over 5 plus 2 over 5, the blue one. And then we can see that here is x-intercept is 2. They are both are function. Actually, it is a linear functions. Example 2. The graph of the quadratic relation is given below. Number 8. Determine if the inverse of the given relation is a function. Number B. What is the domain and range of the inverse of the given quadratic relation? We analyze the graph. We can see the x-intercept is 4, 0. And the y-intercept, there are 2 points. One is the 0, negative 2, and another one is 0 and positive 2. So the symmetry line is axis is opening to the left. And solution A. It has the x-intercept is x equal 4, and the y-intercept is negative 2 and positive 2. Then the function is x equal negative. There are 2 factors. One is y negative 2 and another one is y positive 2. They equal negative y squared plus 4, and it's the blue one. Each one x value exclusive the vertex has 2 y value to correspond to it. You can draw the vertical line to test. Then is the no function. And the inverse relation is f negative 1 equal x squared plus 4. Is opening down the red one. And we can see the y-intercept is 0, 4. The point here. And the inverse relation actually is a function. Because every one value has only one y value to corresponding to it. Example 3. The height of the ball thrown into the air h in meters as a function of time t in seconds is given by the function h equal negative 5 times the prefix square of t minus 2 and then plus 20. Describe the physical factor that restrict the domain and range of any object thrown. Number B. Determine the inverse relation. Number C, graph the two relations. And solution number A, for the function h equal negative 5 and times perfect square t minus 2 plus 20. And when h equals 0, we can get a t. There are two t. One is 0, one is 4. The parabola is opening down, so their maximum is 20 meters. And the domain is t more than or equal 0 to less than or equal 4. The range is h more than or equal 0 and less than or equal 20. And find the inverse equation. At first, put the term with t, and then on the left side, and separate the t. So we can get that there are two t. One is 2 plus the square root of 20 minus h over 5, and the 2 minus the square root of 20 minus h over 5. And then h and t interchange. So we can get h negative 1 equal 2 plus the square root of 20 minus t over 5, and h minus t is 2 minus square root of 20 minus t over 5. Solution C. For the function h equal negative 5 times square root of t minus 2 and then plus 20, the gray one. Yeah. So we can see the opening down. There are maximum point here. And h and t interchange, so we can get h negative 1 equal 2 plus square root of 20 minus t over 5, and then the red one. Another one is h minus 1 t equal 2 minus square root of 20 minus t over 5, and the blue one. So we can see that the inverse relation is no function, because when we draw a vertical line, there are two intersection points. And summary. This class is explain the process to find the inverse relations, including 3 steps. Step number 1, move the terms including independent variable x to the left side. Step number 2, separate x as a single. Step number 3, x and y interchange, then write y into f negative 1x, then I get the inverse relation. This class is going to finish. Thank you for watching and listening. Please share the video to somebody who want to study this course. Thank you. See you next time.